Okay, hi everyone. I hope you can hear me all well and see my screen. No, there's still a few people joining, but we are a few minutes behind the hour, so let's get started. So today's topic is about getting Calico up and running on a on-premise Kubernetes cluster. So let's say if you want to make a small lab and get up and play with Calico, this should guide you through this. First part of this presentation will be a few slides to explain the context, and then we'll try to set up in a live environment Calico and configure some options and show you that it is working. Let me also introduce my colleague Jane. She is also on the call, and myself. I'm Philip, and I'm the techie and your host of today. So that's me. Feel free to check me out. And something. Okay. So let's talk about Calico for a second. So as you know, Calico is a project which is driven by the community, and it's basically offering us open source networking and security. Mostly known for the containers in Kubernetes, but it also works for virtual machines, so you can protect traffic to and from VMs, as well as the host on which your Kubernetes clusters are running. So it's not only container, but it can actually protect the entire environment you have. If you want more information about Calico, check out the projectcalico.org website. If you want to go to the documentation, it's docs.projectcalico.org. Feel free to follow us on Twitter, on GitHub. And if you didn't do yet, please join the Slack channel. We get a lot of questions, and a lot of questions gets answered by the community or people from Calico themselves. So feel free. It's a good way to get started, as well as getting your questions answered. Feel free to drop any questions in the chat. When we do have the time, we will answer them. If not, we'll make sure you get an answer through the Slack channel or by email. So let's get started. So the agenda of today is, let's first discuss in a few minutes what we need to think about when we talk about networking in Kubernetes. And once we've done that, what to think about networking together with Calico. Okay. Right then, we're going to jump into the Kubernetes cluster, configure the Kubernetes cluster, as well as configuring Calico. You'll see it's pretty easy. And we'll make a few examples so that you can play around with it. Of course, as I mentioned, go to the documentation website. There are a lot of quick starts. All the content and examples of this presentation, you can also find them on this GitHub link. So Project Calico, as I said, Project Calico basically are two things. First of all, it's a networking solution, provides connectivity in between VMs, container, and hosts. And on the other side, there is also the security part, which is basically network security policy, so access control in and out of a certain workload. Project Calico is pretty known, the CNI is pretty used, the security part is pretty used quite a lot. So if you go to the major cloud providers, you will probably see links to Calico security policies, as well as most of them tend to use the CNI. That's for the cloud part. We also have on-premise Kubernetes solutions, whether it's Mirantis, OpenShift, Rancher, or something like that. Of course, you can use Calico in there and fully manage these environments with Calico. Okay, let's jump into the things we need to know before we can actually install Calico. So when you're setting up Kubernetes cluster, today we will be using kubeadm. It's a pretty flexible tool. There's a lot of configuration can do, but it makes it at the end very simple to set up Kubernetes. Now, one thing to know is that when you set up Kubernetes, or Kubernetes itself doesn't provide any networking. Kubernetes actually depends on what is called a container network interface, a CNI, which is essentially a plugin that will provide us network connectivity. It's easier said than done, because at one side, when we provide networking, we need to make sure that there is connectivity, routing, overlaying, and so on and so forth. But at the other side, we also have to take care of the IP address assignment, so the IPAM part. When you choose to use Calico, everything will be handled by Calico, although you can split up some of the responsibilities. Now, as I mentioned, we need to set up a default network. And since we're living in an IP world, so it means that we basically have to explain to Kubernetes and to all the components that actually talk to the Kubernetes API, like KubeProxy, for example, to actually explain which network we're going to use. And this is typically referred to as a pod sider. That's something you specify the moment you actually configure Kubernetes. Quite often, it's a /16 network, sometimes 192.168, some will 10/something. Actually, it's pretty okay to use anything as long as it doesn't overlap with existing clusters, existing networks. So it needs to be unique for sure and different in between clusters if you want to connect them. But beside the fact they have to be unique, there shouldn't be much of a problem. Another thing to consider is, and for sure, when we're talking about Kubernetes and Calico, is whether that network you're going to choose, so that pod sider, needs to be only used in a private environment, so within the cluster with no external connectivity, or that network shall be seen on the external network, and so that the external side needs to route to it. In that case, of course, you also have to take care of that so that there are no overlaps. That's one of the cool things about Calico. Your pods can have externally routable IP addresses, which is in big contrast to some other CNI solutions. So the pod sider here is something specific to Kubernetes. That's where all the Kubernetes components look at to see which range of IP addresses are actually used by Kubernetes. Another range to consider is essentially the service sider range. The service sider range is actually a range of IP addresses that will be assigned to what is called a Kubernetes service. As you know, IP addresses are assigned to pods, but it's very dynamic. So if you want to basically connect to a pod and you don't know the IP address or it changes, you typically connect through what is called a Kubernetes service. A Kubernetes service is actually, should I call it, a virtual IP address or non-existing IP address, which is actually handled by IP tables or IPVS. So if pod 1 wants to connect to pod 2, it can actually say, okay, pod 1, I will connect to the service. And the service, which is essentially IP tables, will intercept the request to that IP address. It will choose one of the pods, or IP tables is aware of all the IP addresses of the pods, and will actually do a destination to the correct pod. Services are implemented by IP tables, IPVS, as I said, should be configured on every node. And that's essentially the task of kubeproxy to take care of that. So once a service is defined, kubeproxy will pull the Kubernetes API and make sure all the correct entries are made inside of IP tables. Whether to choose IP tables or IPVS, it's not really relevant to today's topic. Most times IP tables is used, but if you want to use for IPVS, go on. It's quicker at higher rates and larger clusters. Check out our blog. There is a cool blog post on the difference performance measures related to this. So, knowing that we need a pod cider and a service cider, so what can Calico do with it? So the idea of a pod cider is that every pod gets an IP address out of this range of networks and can connect to each other. Now that's easier said than done because at the end of the day, if a pod needs to leave a host, gets into another host and reach the pod, it needs to be aware of where these pods are residing or where at least the IP addresses are residing. So there are a few options in Calico. One is probably the most known is BGP. In that case, all the nodes of a Kubernetes cluster will actually exchange BGP routes. They will make a mesh in between each other. So every node knows which IP addresses or which ranges are actually residing on which host. That means that you don't need any encapsulation at that time. That means that a pod connecting to another pod is actually visible on the underlying network infrastructure. That's all cool as long these nodes are sitting in the same network. If your nodes are sitting in other networks, are routed in between load balancers or something else, you typically need some kind of encapsulation technique. Calico supports IP and IP or VXLAN. Both are encapsulated overlays that work differently. VXLAN might be more interesting because it's basically using UDP, which might be easier on the firewall front. But both will induce overhead, but is a necessity if you need to travel across routers. To make it more performant, Calico supports an option which is cross-subnet, which essentially means that inside a specific subnet, we will use no encapsulation. If we need to cross subnets, we can actually do automatic encapsulation. So that might be a nice thing to configure. For example, if you want to go from one VPC to another VPC in Amazon. Now, Calico itself also need to assign IP addresses. So there is an IPAM function, and this is called in Calico what is IP pool or the IP pool cider. The IP pool cider can be the same as the pod cider, but it's a Calico configuration, or could be a subset. You can have different IP pools within Calico. So you could, for example, take a large pod cider and then create multiple pools which are subsets of it. An IP pool exists across all the nodes. Yeah, you can actually say that an IP pool is on a per node basis, of course, but also on a per namespace basis, which means that every pod which is sitting in a specific namespace will get an IP address out of IP pool 1 or the default pool. And something sitting in another namespace will probably use something or another IP pool. Yeah. So that's one thing to make it more manageable and scalable. On top, to make the routing and the exchange of IP addresses more easily, there's also the concept of an IP pool block. An IP pool block, as you might think, is a subset of the IP pool cider, and an IP pool block is basically a block of IP addresses which is used by a specific node. So everything within that IP pool block can reach each other on the node. Knowing all this, because all these things actually make sure that pods can talk to pods, What if these pods need to reach the outside world? So one thing to consider is whether or not to use address translation if you want to go outside of the cluster. This is called net outbound. If you're using VXLAN or IP and IP across your entire environment, you need to do not outbound because typically the IP addresses are not known outside of the cluster. But if you use BGP, for example, and BGP peering, it might be that the IP addresses are reachable from outside of the cluster. And in that case, you can actually disable outbound NAT in your IP pool. Things we discussed were merely related to everything which is regarding the network. Okay, so one very interesting thing about Calico is that we also implement what is called network policies or network security policies in Kubernetes, or you can use the Calico network policies. So Calico supports as well the native Kubernetes policies as well as an extension to this, which is the Calico network policy. Calico supports two types of policies. One is a network policy itself, so basically control what can access what in a specific pod. Global network policies are typically things which are more global, so not namespace bound. So you can actually say that nobody can enter a pod regardless of any namespace. We'll do additional meetups or presentations around this topic. Feel free to check out our event page and we'll see that content is available. If not, go to docs.projectcalico.org and you will find more information about how to do that. So what is special about Calico network policies? As I said, Calico network policies are an extension to the Kubernetes network policies. It implements basically things like deny, logging, and so on and so forth. So it's not a little bit, it's far more flexible than the standard network policies and pretty easy to use. We can also mix and match Kubernetes policies together with Calico policies. We'll make a small example in the lab. So the setup of the lab will be more or less this. So imagine we have a small microservice existing of a front end, two microservices in between. So front end talks to microservices, and the microservice can talk to backends. A simple scenario. If we're just using CNI and forget 2 minutes about the network security policies, this basically means that it's very hard to enforce that only front end can talk to microservice. Actually, in Kubernetes, everything can talk to everything. Every pod can talk to every pod. That's one of the design criteria of Kubernetes. Now, from a security point of view, this is, of course, not very interesting. So what we typically want to do is a little bit mimic the idea of what we had in the past when we built DMZs and actually implement perhaps some enforcement that says like, okay, maybe I want external traffic to only come into my front end. My front end is only supposed to talk to the middleware services in a trusted zone. And the trusted zone is only allowed to talk to the restricted zone. Well, it's pretty easy to implement this through network security policies, because network security policies are actually access rules, not based on IP addresses, because it wouldn't work in Kubernetes, but based on labels. So we could actually say that pods with a label in front end can only talk to pods with a label of trusted, for example. I'll show you a small example in the demo. There's also a Calico Enterprise edition. Calico Enterprise will add some features on the CNI part, but also adds a lot of functionality on the network security part, like auto creation of policy, preview, staging, troubleshooting, and so on and so forth. But not to forget logging and compliance reporting. So if you want to check out what Calico Enterprise can offer on top of the Calico Open Source Edition, hit this URL, sign up, and you can test it out if you're interested. I'll probably never come back to this slide, so just before we jump into the demo, there are a few other upcoming events. Feel free to join them. We'll announce more quickly, also in the EMEA time zone, for that matter. Okay, so I'm going to stop here the presentation. If you have any questions, as I said, feel free to put them on the channel. And let me open my browser here and show you this. I hope everybody can see it. Let me put this a little bit more enlarged. Nobody can see my screen. Okay. I love you. Now you can. So what you're seeing here is essentially a GitHub page. You can access this GitHub page. I'll send you the link. And this is a workthrough of how to all configure this. So I'm not going to read all this, but the idea will be that we will have a pod cider, as you can see on a /16, but we're going to modify to /24 for Calico. So let's jump into this. I have here 3 nodes. This will be my master. These are 2 worker nodes, and this is just something that will help me. Now, to get started, I actually used Ubuntu 18.04 machines. These ones are running on Amazon, but I tried it out on DigitalOcean earlier today, and it also works. Just make sure if you use AWS with Ubuntu machines that you disable the source destination check if you want to use routable IP addresses. So to get started, just grab some empty Ubuntu machines. I will do that straight away. Okay. And I will increase this size here. So basically, if you follow these steps, nothing complicated, turn off the swapping of the disk, add some repositories. At the end of the day, install Docker, of course, watch IPVSadmin. It's not necessary. TCP dump neither for this, which is something I use. So essentially, if you have Docker, it should be okay. You install kubeadm. This is a complex way of doing it, but if you just install kubeadm, it will work also. Let's enable Docker and make sure kubeadm is ready. So I've already done this on this host. Let me see, I'm struggling with. I already did it on 2 of the hosts, but not on my master. So just to prove it works, we're going to do this. And if everything works well, keys are added. Okay, and then we can go on and basically install already a bunch of our software. As you can see, nothing special here. Just takes a while. That's why I already prepared the other hosts, but it will show that it works. Okay, so at this point, most of the things are installed. We just need to install kubeadmin here. So we'll do that. Once kubeadmin is installed, we can enable Docker and start doing cool stuff. So you can see that installing Kubernetes has become way more easier than it was before. So let's see if Docker is working and kubeadmin is installed. You can see we have 1903 of Docker installed, and we have the newest, or the 18.3 is not the newest at this point, version of kubeadmin installed. Okay, so just let's download the kubeadmin images. So what it will do right now is, just to make it quicker, in the next phase, is it will actually download the kube API server, etcd, and so on and so forth. Once this is done, we're pretty good to go. So these steps, you have to repeat them on every node. As you can see, it takes a few minutes. That's why I already prepared these hosts up front. So the next thing to do is actually install Kubernetes. The only thing we did was actually download the images. So the next thing to do is actually install Kubernetes. And this is done through kubeadmin. So we need to initialize that. You can pass on most of the parameters through flags, but you can also use a configuration file. So let's create a configuration file and copy this. So as you can see, let me first do this up. Okay. As you can see, it basically specifies the service side, so 1049/16, the pod subnet. So this is the kubeadmin pod-sided flag, which is pushed to 16, the domain name that will be used for the services. And you can see that we actually configuring KubeProxy to use IP tables by default. So once this is done, we can actually apply this. So by simply doing kubeadmin init, we'll be actually generating all the certificates, bringing up all the components on the master node. And when this is done, we should actually see an entry like this. It's a good thing to copy paste that one, because actually that's the join command. So that's what we're going to run on the nodes to actually join the cluster. Now, just to explain a little bit how it works, I'm going to do that right after. So please copy this. Don't take this one because it changes. To make sure kubectl will work, we'll also need to make sure that we can run kubectl. So let's see whether it's working or not. And if we do this, let me first copy this. So right now, the only thing which basically has Kubernetes is the master node. So as you can see, there's only one node, master node. Nobody is aware of node 2 or node 3. So if we go to node 2 and we basically add that join command, what will happen is this worker node will connect to the Kubernetes API here, authenticate itself, ask for a certificate so that it can connect in the future. So if we hit enter, we should actually see that node being registered. If we do the same thing on node 3, if we do the same thing, here. So if we do the same thing over here, it should be that fail. Okay, so if everything goes right, that node should be added also. So I have 2 workers node, 1 master. If you pay attention, you can see that the Kubernetes nodes are in a not ready state. The not ready state in this case basically means that control plane is not yet okay. And the reason why is if you do kubectl get pods in kube system, you will actually see that the core DNS, which is responsible for DNS, is still pending. The reason for this is that our CNI is still not up and running. So there is no network connectivity for our pods to get an IP address. So to solve that, we already did this. Let's go and do a more complicated install of Calico, because at the end of the day, you don't need to do this, just to show you that you can modify it and change it. So let's pull the Calico installation YAML, okay? And then we can actually go and take a look in that file. And this is everything you can actually configure inside of Calico. For the purpose of this demo, we're going to change the Calico IPv4 pool. So let's find it where this parameter is. IPv4. Pool. That was not working. IPv4 pool. You see, we have the IPv4 pool settings. One setting to change it is like, in this case, you see that we will use the IP and IP encapsulation. It will work by default on almost everything, but to make it life a little bit more complex, we're going to change it to never. So that means that our pods won't be encapsulated. And if we scroll a little bit down, we also see that we're not going to use the default Calico IP pool, but we're going to modify that to what we want it to be. So we want to be, remember the Calico, the pod size was /16. We're going to use only a subset of this and make it /24. So let's see if this all works out. So let's save this. We disabled it, so let's apply this. If everything gets applied correctly, we should actually see right now that our nodes in a matter of a few seconds will become ready. This basically means that there is a CNI configured on all the nodes, and there is right now connectivity in between the nodes. If we double check on the kube system pods, you will actually see right now that the core DNS pods are actually also getting an IP address and will be running in a few seconds. So right now we've set up Kubernetes with Calico. We modified the basic or default install of Calico. So let's see how we can manage our Calico part within Kubernetes. So to do that, you can do it through kubectl, but it's more flexible if you actually do it through the Calico CTL tool. So let's go and install the Calico CTL tool so we can download it, make it executable, and copy it to a path that we can reach. Now, Calico CTL, as you might expect, needs to connect to the Kubernetes store, or needs to store or access configuration data. So to do that, we need to actually explain Calico CTL, like we explained kubectl before, that it can access configuration data. We're going to use a Kubernetes store. So that means that all the information about Calico is available in there. To do that, it's pretty simple. We're going to create a file which is called calico config. And we're going to actually tell that we're going to use the Kubernetes store. And this is actually the path to the kube config file. So Calico CTL will use the kube config file to actually access the data. So let's write it to disk. Okay. So we have the file. Let's copy that file to the standard location, which is etc calico. And right now, if it didn't make any mistakes, we should be able to see that Calico CTL is running and can access our Kubernetes environment. You can see version 3.14, we're using the Kubernetes. We are on BGP mode, and so on and so forth. So right now, we're at a phase where we can fairly easily start working with Calico. As I said, we installed Calico in BGP mode. So let's see if we can find some information about that. So by running this command, Calico CTL node status, we can actually see that Calico, so we're on the master node, has a peering connection with 105 and 225, which are actually node 2 and node 1. So this is called node-to-node type mesh. That means that every node inside of this Kubernetes cluster has a peering, a BGP peering with each other. So this actually simply means that all these nodes in between the bird processes that are running do exchange which network blocks and so on are used on which nodes. That's how one node can find out where the IP address of another pod is. If you want more information, you can actually see that also. So let's see what pools are in use. There's only one pool that we used in the configuration. You can see that at the pool level, we actually can configure the IP and IP or the VXLAN mode. Remember, I talked briefly about not outgoing. This means that if pods need to connect to the internet, for example, there will be address translated on the outgoing interface of the host. Okay, so IP addresses assigned, or let's say managed by Calico, they will be coming from /24. So means that 1048.1, 1048.2, and so on and so forth are not used. They're only defined at Kubernetes level. So we can create additional IP pools in, for example, 1048.1. And we could say that, for example, they're only available at specific nodes. Yeah. Now, it's always good to know do I still have IP addresses left? Because a question you can ask yourself is, how big should these CIDs be? How many of these blocks do I need, and so on and so forth. So to basically have a good understanding about that, you can actually go and do things like IP show. So that means you can actually see how many IP addresses are in use and how many you typically have. So it gives you a good idea to monitor the IP usage, because just take in mind, we might say like we have thousands and thousands and thousands of pods running on our very large clusters. They all need their own IP address. So managing and planning all this IP pools and blocks is a pretty important thing to do. If you want to get an idea about which blocks are in use, well, calicoctl can show you also the blocks and how much of these blocks are actually in use. You can see that we have three blocks here. Why is this? Well, a block is assigned to a node, so you can actually see that every node basically has a separate /26 assigned from which it will assign IP addresses. If I don't forget, we'll launch a pod and we'll see if these counters increase. Okay. Now, this is from the networking part. Okay, so installed Kubernetes, we installed the Calico CNI, we even customized the Calico CNI to use a specific pool, configure the encapsulation, and so on and so forth. So it's totally not difficult to do, and everything is very well documented on the Project Calico website. Now, if you want to implement the idea we just discussed, like DMZ restricted and so on and so forth, well, that's why we need Calico network policies. So by default, if you install Calico or Kubernetes, there are no network policies, or there are also no global network policies installed, which basically means that everything can connect to everything without any control. So to implement actually the firewall zone policies that we just discussed, we can do that. It's pretty easy, although writing the file is a little bit more cumbersome. But let's see. I cloned this repository, and in that repository, there is a file called firewall zones. So if you scroll through it, you can actually see that, for example, we have a policy for DMZ saying everything which basically has a label firewall zone equals DMZ, for example, only will receive traffic from this external namespace. It's allowed to connect to only things which are labeled as trusted or logging. If you scroll down, you will see that we have the definition for the trusted zone. So everything which has a label of trusted is impacted. And as you can see, everything in the trusted zone is only allowed to receive traffic from things which are labeled as DMZ or trusted, and so on and so forth. So if you have the time, take a look at it. Looks a little bit complicated the first time, but tons and tons and tons of examples on the internet to help you, and also the quick starts at projectcalico.org. So let me exit this and put the proof in the pudding. So to apply this policy, it's pretty easy. It's applied right now, and to check if it happens, you can actually see that right now in namespace default, because don't forget network policies are namespace bound. So there is one DMZ, restricted and trusted. If you would do a describe of these policies, you would actually see the information I just showed you in the text. Okay, so I could deploy the app by copy pasting a link but I always love to play a little bit around and actually test things out manually. So what I will do is I will actually run an Nginx container, and I will label it with fw-zone trusted. Yeah. And I'll see if that pod is up and running. You can see that it is on 48.129. Okay, let's remember this. So right now, if I'm going to use my container I use for testing, as you can see, I'm going to run it. I'm not going to assign it any labels. So that means that it will not be catched by the policies I have in place, which actually means if it's not catched, or sorry, if it doesn't have a label, it will not be allowed access to DMZ restricted or trusted anyway. Yeah. So if I run this, it takes a few seconds to load the container and to pull it. But once this is done, you can actually try to connect to this IP address. And if I didn't tell any mistakes, you will see that it basically fails, which makes sense because if I wanted to connect to resources with a label of trusted, according to the policy, I have to be in the DMZ zone, and I should have a label which is called DMZ. So let's see if I add this label. I'll get any further. So right now, Hakon will be booted with or started with the DMZ zone label. So if you repeat the same test and we try to connect to the service, we actually see that the Nginx container is responding. Is this cool? You might think, cool, but I don't have any logging, or this might be pretty hard to troubleshoot my first time. Well, that's exactly why there is Calico Enterprise. So all the logging, all the management of the policies and so on and so forth can actually be managed through Calico Enterprise. Check out the event page. There are quite a lot of demos or YouTube showing you these screens. This is more or less what I had to say. We're more or less on time. We do have time to answer some questions. So let me see if I can find Zoom and the Q&A part.
Let me know if you want me to go through those questions. We have 3.
You can see my screen here? Yeah.
We can see your screen, yeah.
So I see one question. If pods get external IP addresses, can it be reached directly without services ingress from outside? The answer is yes. So they don't have to be external IP addresses. It can be a private IP address as long as it is accessible through means of a router, routing-wise, yeah, you can access them. That's the cool thing about BGP. If you look further on the internet, you will see BGP peering or route reflector. For example, the Kubernetes nodes might connect to a firewall, for example, exchange routes so that the firewall knows or the router knows where to reach these IP addresses. A lot of data center design are based on this. IPv4 that main package is not needed just because we use this demo for other reasons. So the install I showed you is a little bit more, it's more overhead than it actually should be in real life. Can I install Calico on my existing Kubernetes cluster? You can, although I'm going to be technically honest, it's not as easy as it sounds, but there is a migration path from Flannel to Calico to fully replace it, or to use network security policies on top of Flannel, which is typically known as Camel. But it's on the documentation website. Feel free to go to docs2project calico.org and you will find it. I think the IP block size of the worker node, you can see it if you do IP show blocks. The last question, Calico pool CIDR must be a subset of the cluster pool CIDR. As of my understanding, yes. So the pool CIDR must be a subset of it. In all honesty, I tried it with an IP range which is outside of the pod CIDR, and it worked. But the problem is like kubeProxy, when it needs to know when to address translate and so on. So to actually configure IP tables or IPVS, we'll look at that pod CIDR. So I guess you might have scenarios where this will be okay, but officially and in the documentation, it says it has to be a subset. I think these are more or less all the questions.
We have a couple more. I don't know if we're seeing different chats. We got one saying, how many nodes are in your cluster?
Sorry, which was the question, Jane?
So there's three more here. How many nodes do you have in your Kubernetes cluster, Philippe?
In my case, I only have 3 nodes.
And AJ asks, would like to know why we need to disable the swap space.
It's a good question. I think it's for performance reasons. I ran into a few times in issues when you didn't do it, but it's also recommended when you do the kubeadm install to actually disable the swap space. But I guess it's for performance reasons.
And the last question, sorry. Any specific reasons to provide these options for IP pool per node and IP pool per namespace?
Yes, you don't have to, because at the end of the day, you could just copy one line and make it all work. For example, some people have nodes that they dedicate, for example, only to reach outside. So let's suppose nodes that will handle incoming traffic, ingresses, or ingress type of traffic. You might use an IP pool to basically assign to these nodes, and you might use other IP pools for traffic, which is, for example, only internal. So that's one reason to do it. For example, you might do it per namespace. For example, you might have a different IP pool per namespace, and one of these IP pools you might actually inject with BGP into the external world. So you might have an IP pool which is externally reachable through BGP, while ours are not. It's more like a design question, but that's exactly the flexibility of Calico and the CNI. For example, I'm not going to name any names, but you can use other CNIs where you don't have that flexibility, and you basically have one big block of IP addresses. So all these blocks and pools and the specification on a per pool, for example, encapsulation or not, is just there to make it more flexible, easier to configure, and so on and so forth. There are other functionalities, for example, that we added recently in Calico Enterprise, which is egress gateway pods. So these are other technologies that actually rely on the use of IP pools, different IP pools.
And then final question, do you have services.yaml and a root.yaml there in your config that you could show us, Philippe?
Sorry, which one?
Services.yaml and root.yaml.
And where have I never, it doesn't ring a bell, but where do you see it?
It's a question from he said if for the pod created.
Where is the pod create? I really don't know. You mean this one? Let me see, there's a Q&A. Otherwise, please send me the question in chat or email, and I will reply it. I see it. Can you also use services YAML? It is a different network also. Route created as well. Is it same? I need to look into this because I have no idea where this refers to. Any specific load balancers that you suggest for an on-premise cluster with Calico? Not specifically, but there are a few options. You can use Nginx for that, HAProxy for that, Traffic if you want, or some commercial ones like F5 or AVI networks, which have pretty good integration. But it's true that from a load balancer's perspective, if you want to integrate it, it's not as much an integration with Calico, but more like an integration between Kubernetes and the load balancer. So once you create the services in Kubernetes, that it automatically configures the load balancer. There are a few options available.
I don't think we have any more questions. Good job.
Okay, thank you.
Thank you all for attending.
Bye.